Hello everyone. Welcome back to the channel. Today, we are diving deep into a fascinating and cutting-edge topic, smart contracts overview. This is an advanced concept, especially relevant for all you brilliant Java developers out there who are keen to understand how this revolutionary technology works and how Java fits into the blockchain ecosystem. We will explore what smart contracts are, their core components, how they manage state, and how Java applications can interact with them. By the end of this tutorial, you will have a solid understanding of smart contracts, their implications, and practical insights into integrating them with your Java projects. So, grab your virtual whiteboards and let us get started on this exciting journey. Alright, let us begin with the very basics. What exactly is a smart contract? Imagine a traditional paper contract, but one that is stored and executed on a blockchain. It is a self-executing agreement where the terms of the agreement between buyer and seller are directly written into lines of code. The code and the agreements contained therein exist across a distributed, decentralized blockchain network. This means smart contracts are immutable, tamper-proof, and transparent. Once deployed, they cannot be changed, and their execution is guaranteed by the network without the need for intermediaries. For example, a simple vending machine is a basic form of a smart contract. If you put in money and select a drink, the machine automatically dispenses it. On a blockchain, this logic becomes trustless and verifiable. Now, let us look at the core anatomy of a smart contract, conceptually mapping it to Java. A smart contract typically has state variables, which are like instance variables in a Java class, storing the contract's data. Then, there are functions, which are analogous to methods in Java, defining the logic and actions the contract can perform. Finally, events are used to log information on the blockchain, much like logging in a Java application, allowing external applications to track contract activity. Consider this simplified Java representation of a basic voting contract. It has an owner address, a total votes counter, and a vote for candidate method. This Java class provides a clear conceptual blueprint for understanding the structure of a smart contract, even though actual smart contracts are written in languages like Solidity or Viper. It helps us visualize the data and behavior. Moving on to our second core concept, immutability and state management. Once a smart contract is deployed on a blockchain, its code cannot be altered. This immutability is a cornerstone of its trustworthiness. However, the contract's state that is, the values of its variables can change as functions are called and transactions are processed. Each state change is recorded as a new block on the blockchain, creating an immutable history of all interactions. Think of it like persistent storage for your Java application, but one that is cryptographically secured and distributed. Our voting contract example shows how a vote for candidate method modifies the total votes state variable. This change is then permanently recorded. Understanding this distinction between immutable code and mutable, but historically recorded, state is crucial for designing robust decentralized applications. Let us put this into a practical context. How would a Java application interact with a deployed smart contract? Since smart contracts run on a blockchain, your Java application needs a way to connect to that blockchain network and send transactions or query data. This is typically done using a Web3 Java library, such as Web3j for Ethereum. Our example here shows a blockchain client class that conceptually represents this interaction. It has methods like connect, deploy contract, call contract function, and react contract state. Imagine call contract function sending a transaction to invoke vote for candidate on our deployed voting contract and react contract state fetching the current total votes. This mock client demonstrates how a Java backend or a desktop application could seamlessly integrate with a blockchain, acting as a bridge between traditional applications and the decentralized world. While working with smart contracts, both in their development and in Java interactions, there are common pitfalls to avoid. One frequent mistake is neglecting security audits. Smart contracts handle valuable assets, and a single bug can be catastrophic. Another is underestimating gas costs. Inefficient code can lead to very expensive transactions. From a Java integration perspective, common mistakes include not handling asynchronous blockchain responses properly or failing to validate input from the contract. To overcome these, always prioritize thorough security audits and testing. Employ best practices like using established libraries, implementing proper error handling, and carefully managing transaction nonce. For Java, this means robust exception handling, clear logging, and understanding the blockchain's eventual consistency model, ensuring your application reacts appropriately to transaction confirmations and state changes.